Hello. I just wanted to go over some of these stats questions. So I'm not going to go over question 1 because actually me talking about it isn't going to add anything to it. That's in the work solutions. I am going to go over question 2 because I need you to remember how you draw your Venn diagram. I'm really sorry that this is so small, but my printer's run out of ink, so I can't print a bigger copy. So hopefully you can see it on your screens. If not, I did email it you, so you'll be able to print it off larger. So when we got this, there are 180 students in a college following a general course in computers. Students on this course can continue to take up 3 extra options. So there's systems support, developing software, and networking. So I'm going to call them systems support will be S, developing software can be D, and networking can be N. So, sorry, it's a bit scruffy. There's the start of my Venn diagram. So whenever you label a Venn diagram, please remember to start at the intersections. And also, I've forgotten, sorry, I'll write in a darker pen. So you start at the intersections. So if I look through this list, it gives me 1 by 1 by 1, and it ends up with 4 take all 3 options. So all 3 options is the most intersecting intersection, so I'm going to put that in there. 4 of them take all 3 options, and I've done that now. It says 40 takes systems support and networking. So systems support and networking is this region here. So if it's 40 altogether, I've already used 4, so that must be 36. 28 take networking and developing software. So networking and developing software is 28, so the overlap is here. 4 of them are used up there, so I've got 24 in the other part. Okay, and carry on working out from that. So 34 take developing software and systems support. So developing software and systems support is here. There's the overlap. 35 take that. I've already used 4. That must be 31. 81 take networking. If I take out the bits that I've already used out of networking, I'm left with 17. 70 take developing software. So I've already, if I start with 70 and take out 31 and 4 and 24, I'm left with 11. 112 take system support. So I've got 112 take out 31 and 4 and 36, which leaves me with 41. And finally, I know there are 180 students in the college. So if I take out everything that I've used up so far, there are 16 who don't take any of those choices. Then it asks you to find the probability. So student is chosen at random. Find the probability that it takes none of the 3 extra options. Well, the people who take none are these people down here. So the probability that they take none, you see that, is 16, and we've said that it's 180 altogether, and then that will simplify to 4 out of 45. Then it says it only takes networking. So it says networking only. So networking only will be this section here, 17, because that's networking and systems. That's networking and developing software and system support, and that's networking and developing software. So networking only is this 17 here. So only networking. See, can't write. Is 17 out of 180. And then lastly, it says, given that students who take system support and networking are eligible to become technicians. Given that a randomly chosen student is eligible to become a technician. So this is where we restrict, because it's a conditional probability, something is already given, we restrict the area on our Venn diagram. So it says, given that they are eligible to become a technician. And to be eligible to become a technician, you have to take system support and networking. So the people who do system support and networking are this shaded section here. So everybody in there is eligible to be a technician. And because it's given that they're eligible to be a technician, that's the only region that I care about for this part of the question. So for part C, given that the randomly chosen student is eligible to become a technician, find the probability that they take all 3 extra options. So in this restricted shaded bit here, the probability that they take all 3 is 4. The total amount in this restricted section is 40. So the probability is 1/10. Okay, I hope that makes sense. Oh no, I've done it all off the page. So sorry. I hope that makes sense. Then let's have a look at question 3. So this is really tiny. I don't want to go over all of question 3. I just want to go over the first part. So for question 3, a random sample of distances travelled to work for 120 commuters from a train in Devon is recorded. The distances travelled to the nearest mile are summarised below. Estimate the median. So the first thing we need to do is add up the total frequency. Or actually it tells us in the question it adds up to 120. I hope you can see this okay. So we know that the median... Let's go to the side here. So we know that if there are 120 commuters, the median is the 60th person, is the 60th value. Okay, so if we go down here, this has got 10 commuters in. So I haven't got to the median yet because I've only got 10 people. The next one has got 19. So if I look at both of them together, I've got to 29. So I haven't got to the 60th yet. If I look at the next one, if I add on 43 to that, I get 72. So the median is somewhere in there. That takes me up to 72. I only want the 60th person, so I need to go into this category. If I start at 29, to get to 60, I need to go 31 people into that category, and the category is 43 wide. So I need to go 31 43rds into there. Into the category. The other thing I need to look at before we can then work out what that is, before we can then do interpolation, is to look at these boundaries. So if we look here, I know this has been rounded to the nearest mile. So this is actually continuous data that has been rounded. So I need to think about what values would these truly be if they hadn't been rounded. So if it goes from 0 to 9, you can't, the lowest it could be is 0. The biggest it could be, if I click D for distance, is 9.5. It couldn't actually be 9.5, but it could be nearly 9.5. So we have to change those boundaries to make them into truly continuous boundaries, because distance is continuous. It's just that it's been rounded in this table. If I look at 10 to 19, the smallest thing that would round to 10 is 9.5. The biggest thing that would round to 19 is 19.5, but it couldn't be 19.5, so I've changed the inequality there. In the 20 to 29 category, the smallest thing that would round to 20 is 19.5. The biggest thing would be 29.5. So you can see that I've changed the boundaries for those. I don't need to carry on because actually the median, which I care about, is in this category here. So I don't need to go any further with that. So we've gone back to this. I know to find the median, I need to go 31 43rds into that category, into the 20 to 29 category. So I need to go 31 43rds. That's the proportion I need to go into it. The category is from 19.5 to 29.5, so it's 10 wide. That will tell me how far into that boundary I need to go, but the boundary doesn't start at 0, it starts at 19.5, so I then need to add on my starting point of 19.5. And when we work that out, we get 26.709, so the median would be 26.7 to 3 significant figures. Okay. So just remember, when you've got continuous data, if it's already been rounded, you need to unround it, put it back into proper continuous form using your inequalities, and then use interpolation to see how far into the category you need to go. For part 2, it says estimate the mean and the standard deviation. It gives you the summary data here, so all you need to do is substitute that into the formula. So you know for the mean is the total frequency, which they've called, the total data, so the total of the frequency times the x values, divided by the total frequency, or n if you prefer. So 3,552.5 divided by 120. So the mean is 29.6 to 3 significant figures. And then for standard deviation, see that? Standard deviation is the square root of the sum of the x values squared divided by the total frequency, or sometimes we write n for that instead, subtract the mean squared. And all you're going to do is substitute in the summary data that they've given you in this question. So the sum of the x values squared is 138,000, oopsie, not a point there, and 43.125. The total frequency is 120. For the mean, I am not going to use this value here because I've rounded it. I'm going to use this instead. So 3552.5 over 120, that's the mean squared, and then square root the whole lot. Oh, I've gone off the page again, so sorry. And if you put that into your calculator, you should get 16.6 to 3 significant figures. And the reason that the median is less than the mean for this data is because if you look at the table, most of the data is between 0 and 39, the biggest quantity of it. But then you've got some high values here. You've got 1 in the 80 to 89, 1 in the 3 in the 70 to 79 category. These are included in the mean, but they are not included in the median because the median only takes into account up to the 20 to 29 category. So that's why the mean is higher than the median, because the data is positively skewed. It's got these large values at the end which affect the mean. They pull the mean up, but they do not affect the median.